Yes, good day. Today I have a very small question, and as usual, the purpose of these questions is for us to practice a variety of different questions, which is what I think is a good strategy if we have to pass physics exams. Okay, we have a question which goes like this: an object is initially at rest, and it means the initial velocity. I can write the initial velocity. Yeah, well, what would be the initial velocity if an object starts from rest? Yes, the initial velocity is zero. Always, very important. If you are told that the object starts from rest, then it means your initial velocity is already given. Then an impulse J acts on the object, and it is said that an impulse of magnitude J acts on the object, and the object accelerates uniformly. Yeah, so it means the object will achieve some and some velocity at some point, at some time t. Yeah. Okay. So there will be some velocity there, right? Then the question says, what is the change? Express the change in kinetic energy of the object. Yeah, in terms of J. So what we want is change in kinetic energy. Right? That is the question. So I want us to, I think the variety of options were given as possible answers, but I'm not going to put them there. I'll just work out, because the idea is you work it out first and then you compare with what is given, right? Because quite often in multiple choice questions, the trick is that sometimes you can work out your sum correctly, and when you check the options provided, you might not find the solution that you found there. Yeah, and like in this case, you see that you need to apply a lot of mathematics, not a lot, just to apply your mathematical ability to solve problems. Okay, so the first thing you ask yourself is, J, what is impulse? Yes, who remembers that? Good, right. Impulse is change. Impulse is change in momentum. Very good. Or impulse is, remember there are two ways of calculating impulse. Impulse is, yes, the product of the net force and the contact time. Okay. But in this case, the T is not really given. You are just given velocity, initial velocity, the moment and final velocity. So we can calculate change in momentum. Good. So let's start there. So we are going to say, we can even do it here. So your J is equals to change in momentum, which is momentum. It is a ball of mass m. So it's mass times velocity, final velocity, minus mass times the initial velocity. That gives you your change in momentum, which is this initial velocity is 0. So that gives you J is equals to, because this is 0, so all of that is 0, J is equals to mv. So you want to express your change in kinetic energy in terms of J. So what you're going to do is kinetic energy will be change in kinetic energy, also similar, very similar. Or what would it be? Yes, very correct. You guessed right. You're right there. So it is the final kinetic energy minus the initial kinetic energy. So that is you have mv squared minus half u. Can I put 0 there? 0 squared for 4, so that we accelerate. Yeah, because I know that you already know. So all of that goes. So your final answer is that your change in kinetic energy is half mv squared. But they want you to express this in terms of J. But we've got a v squared there. right? So in this case, the option that was given there, you had to make your expression for j to have a v squared in it. So I can actually say, if I square this thing, it will be m squared v squared. That will give me j squared, right? Are you following? Good. So it gives me that is j squared. So how can I make my final answer look like this? So I will just say my change in kinetic energy is equals to half. Can I write it like this? That m squared v squared. But I put an m squared which is not there. How can I correct that? Anyone? How can I make correction on that? What? How can I make a correction there? Divide by m. Very good. Yes. So we are going to divide here by m. If you look at my expression, my one-term expression for the kinetic energy, change in kinetic energy, it is exactly this. Right? I just rewritten it in a form that suits what I'm looking for. Because if you divide that m into that m squared, you still have half mv squared. So now I can rewrite it as half m, no, not m now, m squared, v squared is j, half j squared over m. Good. And it was given as it was given like this, change in EK equals j squared over 2m, which is this. Very good. Well done. There was another question almost similar to this, but they were talking about the initial velocity was 0, final velocity was v. You could calculate j as well, but they wanted to express the displacement of that object, which started from rest in terms of j. So you would use, in that case, if I express, let me use this space, you would say, use the expression for displacement, which is delta x, or s is equals to u plus v, average velocity, over 2, that's the average velocity, times t. Initial velocity is 0, so the displacement there is is going to be v times t over 2, because this one initial velocity is 0. Good. And then your j is mv. Yeah, your j is mv. So what you have to do, you would have to make this mv. So your displacement would be mv times t, but m was not there. So I must divide by m there to get to the original. So the expression that was looked for there, is it clear there? Yeah, I said Vt over 2, right? Then let me move to the top part there, because it's not clear there. So it would be, I make it mv over m, which is the same thing, and that 2 is still there. It's Vt over m, so that gives you the displacement. So that you replace that with j. So the final answer in that case for the displacement in terms of j was jt over 2m. I guess you follow this. Right, guys, please, if you enjoy my lessons, please, I kindly ask you that you hit the subscribe button, or just do like, share it, and please also make a comment. If I've overlooked something, just say, oh, but this is very good, or this is, you overlook this. Yeah, so that we all learn. We are learning is a continuous process, right? So thank you very much. I hope you have enjoyed this. Thank you.